Hello everyone, good evening. Hope you're doing well. Who are there? I can see many comments here. Okay, the same person has written. Fine. I'm just going to see what all things we have done. And let us try to some of the questions from the chapters which things which we have learned. Hello everyone. So as we move on, I just want to encourage you that if you have not subscribed our channel, please subscribe. And if you have not, hello. Yeah, good afternoon. And if you have not pressed the bell icon, please press the bell icon so that you may not miss any information or notification from our side. And you can visit our website www.letstute.com for a wide range of courses on science and maths. I just want to see what all things we have done. I'm just going through. Just give me a second. Okay. So we were doing coordinate geometry, and we have done different things. Like we have seen what are coordinate system and what are geometry related to coordinates. And we have seen what is distance formula. We have seen section formula, and we have also seen the area of triangle. So I was thinking, let us solve a few questions today, and just do some revision. What all things we have gone through. Okay. So hope most of us were there in the previous lectures. If you are not there, it's absolutely fine. We can definitely go through what all things we have done. I'm fine. Thank you very much. Hope you are doing well. Let's go for the things. Coordinate geometry. Coordinate geometry. This is the chapter we were looking into. So first of all, we have learned what is coordinate geometry. Let us take it as CG. Okay. So what we have understood is we have coordinate axis. We have coordinate axis, correct? And generally we take it as x and y. We are talking about two dimensional, so x-axis and y-axis. Okay, they are this is called as coordinate system, and we have origin over here, and whatever point we want to plot, we actually locate according to x-axis and y-axis. Suppose I want a point which is 2 units away from y-axis and 3 units away from x-axis. So I'll say that the point is here, correct? 1, 2, 2 units. Let me take it separately. Okay, I'll just remove this. Yeah. Okay. So 1, 2, and 3, and the point is here. This is 2, 3, correct? So this is the location of a point. Location of a point is given by x coordinate and y coordinate. X coordinate is basically the point on x-axis. Y coordinate is basically the point on the y-axis. So this is the point. The location of this point is 2, 3, and this is x coordinate, and this is y coordinate. And we have seen that x coordinate is called as abscissa. Okay, why am I saying this? Let me write over here. This is abscissa, and y coordinate is called as ordinate. And whatever geometry is related with such kind of coordinate system is called as coordinate geometry. And in coordinate geometry, we have seen different things, we have learned different things, and we have seen what is distance formula. So the first thing which we learned is distance formula. Distance formula. And we have understood that whenever we know the coordinates of 2 points, we can use this formula to find distance between them, correct? Like suppose there are 2 points A and B, and the point is suppose 1 comma 2, and the point here say 2 comma 3. We can find the distance between these 2 points. Okay, so what was the formula? I'll just write over here. Let us go down a bit. First of all, we consider the points given as x1 y1 and x2 y2, and using these coordinates we find the distance between them. We take it as d generally, and the formula was square root of x1 minus x2 the whole squared plus y1 minus y2 the whole squared, correct? And we have also seen that this formula can also be written as x2 minus x1 whole squared plus y2 minus y1 whole squared. Since we have squared of each term, it doesn't matter if we are subtracting x2 from x1 or x1 from x2, correct? Because at the end, when we are squaring, both will be giving us same quantity. So this was the distance formula which we learned. We also seen the derivation, how it is derived. Okay, and we also seen some questions that whenever we have 2 points, how to find the distance between them. Then we have seen what is section formula. Section formula. In section formula, we have seen that if we have a line segment joining 2 points, say A and B, and the point of A may be x1 y1 and point B be x2 y2. Suppose we have third point C, which is x3 y3, and say C is dividing the line segment in the ratio m is to n. Then using these ratio m and n, we can find the coordinates of the third point, which is dividing the line segment AB. That's what we have seen. So how to find that? Let us just go down a bit. Okay, so the coordinates of C, that is x3 comma y3, we can find it by using the formula mx2 plus nx1 upon m plus n, and here my2 plus ny1 upon m plus n. So this is the formula for section formula to find the coordinates of the point which is dividing segment AB internally in the ratio m is to n. So this let me take it as internal section formula, and we also have external section formula. Let me write over here. So what is external section formula? Suppose we have a line segment AB, and say there is the third point C dividing line segment externally. Okay, so in this case, when we have the points, we take it as x1 y1 and x2 y2, and the unknown point we take it as x3 y3, and this C divides AB. That means we need ratio of the distances of C from A and B. So in this case, suppose distance between C and A is m, and distance between B and C is n. So in that case, we can find the coordinates of the third point C x3 y3 with the formula m x2 minus n x1 upon m minus n, m y2 minus n y1 upon m minus n. So this was the formula for external division. Let me say external section formula. We can write it as external section formula. So this external section formula is basically derived from internal section formula itself, but it is just a small arrangement by which we get negative sign. So we can directly remember even the formula given in this way. So this is internal section and this is external section, correct? And then we learned a few derivations out of internal section formula. Out of them, the first one was midpoint formula. Midpoint formula. So what is midpoint formula? Midpoint formula was, if we have a line segment AB, and if we want the middle point, suppose we have the coordinates x1, y1 for A and x2, y2 for B, then the middle point, let us say C, that is x3, y3. We can find the coordinates of C, x3, y3 by using a midpoint formula. So that is x3, y3 would be equals to x1 plus x2 divided by 2, y1 plus y2 divided by 2. So this is basically taking average of the coordinates of the 2 points which we already have as an endpoints. Okay, so that's how we try to figure out the midpoint. And we have also learned in section formula how to find the center of the triangle. So basically it is called a centroid. How this happens is, when we have a triangle, let me draw a triangle. Okay, so we have, suppose, triangle ABC, x1, y1. This is say x2, y2, and say coordinates for this is x3, y3. Suppose this is the centroid. Generally we call centroid as G, and the coordinates of G can be figured out using the formula x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3. So this is the formula for finding the centroid of the triangle. So basically centroid is center point of the triangle, which is found out by the point of intersection of medians from the vertices. Okay, if you draw a median from A, B and C, all the three medians will be intersecting each other at point G. So G is the centroid or center of triangle, we can say in this fashion also. So this is a formula which we understood that it came from the section formula, derived from section formula. One of the facts which I wanted to let you know is, when we have a median, okay, so this is the median always divides, the median divides the point G divides the median. Suppose this is AD in the ratio 2:1. So this is the fact which we should know. It's simply the point G always divides the medians in the ratio 1:2:1. So when we apply this ratio and all the points, we definitely going to get G equals to this: x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. And what else? What else we have learned? We also seen what is the area of triangle, right, in coordinate geometry. The last concept which we learned, area of triangle. In area of triangle, we have seen that if we have the coordinates, let me take a triangle. If we have the coordinates of the vertices, then we can find the area of this triangle. So let us give the name as A, B and C, the vertices. So triangle ABC, area of triangle ABC would be 1/2 x1 multiplied by y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So this is the formula for area of triangle when the vertices are given. So we need to understand that what we have learned is the three, whatever the points we are considering, they are cyclic, right? If you see the position, it is 1, 2, 3, then 2, 3, 1, then 3 1 2. So that's how the points are selected. To it is a trick to remember how to remember this. Okay, the x from the first position, y's are from the second and third position. Similarly, in the next term, x is from the second position and y's are from the third and first position. Similarly, for the third term, x is from the third position and 1 and 2 are from the first and second position. So this is how we take the points of coordinates of the points of the vertices of a triangle to find the area of triangle, correct? Now, how to find the area of triangle we have seen with some examples as well, but today we are going to solve some questions further. So before moving ahead, I just want to remind you that please subscribe our channel if you are not subscribed it yet, and you can also press the bell icon to never miss any update from us. And you can also visit our website www.letstute.com for a wide range of courses on maths and science. Okay, so we are going to see a few questions from the different types, so that the whatever things we have learned will be ingrained. Okay, so it is just kind of a revision what we have learned till now. So examples. Okay, fine. Okay, the question is, determine if the points 1 5, 2 3 and -2 -11 are collinear. We have to determine if these 3 points are collinear. Now, how to find that these 3 points are collinear? Collinear in the sense the 3 points are on the same line. Okay, how to find that? Suppose this is A, this is B, and this is C. So let us say A is here, B is here, and C is here. Now the question is how to find that they are collinear. We can use distance formula, of course, we can use that, but we can also use area of triangle to find if they're collinear or not. Okay, how to find using area of triangle? What do you think? Whenever the 3 points are collinear, means they're on the same line, then that means they are not going to form any triangle. Correct? Correct. Suppose if the 3 points are in this way, not collinear but slightly closer to the line joining this point A and C. Suppose B is closer to A and C but not on the line, but still in that case we have a hint of triangle, right? Even though it is very close, but we still have a triangle. So when we have a smallest of the triangle, we'll definitely have an area, correct? But when they are collinear, they're on the same line. That means triangle is not possible and area is impossible to find. So what we are going to do is apply the area of triangle formula on these 3 lines, these 3 points. Okay, and when the area comes out to be 0, it is understood that the 3 points are not making triangle. When 3 points are not making triangle, that means they are on the same line, and when they are on the same line, we can say that they are collinear. So that's how we figure out, correct? So let us try to find the area of triangle. Let us take it as x1 y1, x2 y2, x3 y3, correct? So the area of triangle ABC, that would be equals to half multiplied by x1, that is 1, plus y2, that is 3, minus y3, that is 11, negative 11, so it will be positive 11, correct? Negative 2, so sorry, plus 2, because we are going to use the formula further. X2 is, we are done with x1, now we are doing with x2 multiplied by y3, correct? Y3 is negative 11 plus y1. What is y1? Y1 is 5. Correct? Fine. What about the next term? x3. x3 is -2. And here y1 plus y2. y1 was 5 and y2 was 3. You can just figure out if things are fine, because that's what we learned just now, right? x1, x2 and x3. Correct. Let us just try to see what we are done is correct or not. So 3 minus 11 minus of minus 11, that is positive 11, that's correct. To negative 11. Okay, we have taken positive here. It's not positive, it should be negative. Correct. We'll check here also. Okay, so it would be y3 minus y2, so y1. So we took 5, but it has to be negative. Similarly, x3, and we are subtracting y2 from y2 from y1, y2 from y1, right? So x3 multiplied by y1, that is 5, minus y2, so that is 3. Yeah, now the formula is correct. Now when we apply the values, let us see what we are getting. 3 plus 11, it is 14, plus 2 multiplied by -5, -11, it is -16, and this is 5 minus 3, it is -2. So therefore this should be equals to half multiplied by 44, and this should be minus 32 minus 4. So this would be 1 by 2, 14 minus 36. So 14 minus 36 would be 22, correct? -22. Fine. So that would be equals to -11. But this is area. Area can never be negative. So it would be area equals to modulus of -11. So that would be 11. So now looking at this, we see that the points are giving us some area, right? When points are giving us area, then we can say that the points are not collinear. Correct? Because since they are not collinear, they are giving us a triangle. And since we are getting a triangle, we are getting an area. Otherwise, we won't be getting it. So that's one way of looking at things. But we can see also in other way, right? Like here, what we'll do is we'll try to find the lengths of AB, the lengths of BC and AC. And we'll see that the bigger length is equals to sum of the two minimum lengths. I mean the smaller lengths. When they're equal, then we say that the 3 points are collinear. Okay, so that's what it meant. So let us check even in that way. Okay. So since we have taken A as 1, 5, B as 2, 3, and C as -2, -11. Okay, I'll just go through the point. Okay, I was just checking the point was correct, what we have taken. Yeah, fine. Okay, so first of all, let us find the length of AB. Okay, length of AB is, we're going to use this and this. So 2 minus 1, so that is 1 squared, plus 3 minus 5, that is -2, the whole square. So that would be equals to 1 plus -2 squared, it is 4. So that would give us square root of 5. Correct? Let us find the length BC. Correct? So in that we are going to use P and C. So -2, -2. So that will be -4. negative 11 and negative 3, that would be negative 14. This is looking like positive, which is not exactly what we are thinking. So we are going to, this is not the thing what we are seeing. Okay, so negative 4 squared and negative 11 and negative 5 is negative 14 squared. Okay, so this would give us 16 plus 196, correct? Yeah, so that would give us 212. Okay, so here we got BC as 212. So now the chance is to find the length of AC. So in this case, negative 2, negative 1. So that would be negative 3. And negative 5 and negative 6, it is negative 5, it is negative 16 squared, correct? Negative 2 minus 1 is negative 3. Negative 11 minus 5, it is negative 16 squared. So what we are going to get is 9 plus what is 16 squared? 16 squared is 256, correct? It should be 256, right? 31, yeah, 256, correct. So what you're going to get is 265. Okay, so looking at the numbers, every number is in the root, so we can easily find out which one is bigger. Okay, so this is bigger, so therefore AC should be equal to AB plus BC. But is it happening? Of course not, it is not happening. So AC is not equals to AB plus BC. So in this way, we can say that ABC are non-collinear points. Okay, so we have seen two methods to find if the points are non-collinear. One by using area of triangle, and other by using the regular way, like how we do by checking the bigger distance, bigger length should be equals to sum of the smaller lengths, which are consisting the bigger length. So in this case, it is not satisfied. So we can say that the 3 points are not collinear. Okay, so that's what even the other case also says. Okay, so therefore from AB, BC and AC are collinear. Yeah, so that's how it is. Sorry, are not collinear. Which are not collinear? A, B and C, correct? So looking at these lengths, we can say that the 3 points A, B and C are not collinear. It's as simple as that. So it was quite interesting question that we have used even the area of triangle formula, and also we have used the distance formula. Yeah, fine. Then let's see for one more question which we can solve. I'm just checking what question we can solve. Okay. Let us take find the coordinates of trisection of the pointers. Okay, we can talk about the trisection, because in the when I was teaching section formula, a student was asking about trisection. So okay, this is a good option to start trisection over here. Fine, we can use that. Okay, let's solve a question based on trisection. Fine. We're going to use the formula question of trisection. The question given is there are 2 points, 4 comma -1 and -2 comma -3, and what we have to do is we have to find the 2 points which are trisecting this code, the line segment. Let us say this is A and B. So when we want the point of trisections, that means we want these 2 points which are dividing the line segment into 3 equal parts. Let us take it as C and D. Okay, and the point A is 4, -1. 4 and -1, and point B is -2 and -3. Okay, now what we have to do is we have to find the coordinates of C and D. Now you can see that the line segment is divided into 3 equal parts. Let us take it as 1, 1 and 1. Okay, so we know that if we are trying to find the point C, it would be dividing line segment AB in the ratio 1:2. If you are trying to find the coordinates of D first, then it is very much clear from the diagram that D is dividing segment AB in the ratio 2:1. Correct? Now, suppose if I go for C, okay, then what happens? The ratio would be 1 comma this full thing, so that would be 2. Correct? So the ratio would be 1:2. Correct? Now we have to find the coordinates of C, so that would be M x2. So in this case we are going to take this as x1 y1 and this as x2 y2. Correct? So your M is 1. Anyway, I'm writing the formula here first. Mx2 nx1 upon m plus n, my2 plus ny1 upon m plus n. Okay, so now when we apply the values, what we are going to get? 1 multiplied by x2. What is x2? So this is our x2, so this would be -2 plus n. What is n? N is 2, and x1 is what? X1 is 4. So therefore we are getting m plus n. M plus n is basically here, right? Addition of 1 and 2. So we are going to get 3. Correct? And here m is 1, y2 was -3 plus n is 1 and y1 was -1. So m plus n, that is 1 plus 2, it is 3 again. So now let us see what we are getting. We are getting -2 plus 8 upon 3, and here -3, -4 upon 3. So what we are getting is -2 plus 8, that would be 6. So 6 by 3, and here we are going to get y3. Okay, here we have done a small mistake. We have taken 1 and in both the ways. Here we should take 2. So this would be I have done something weird. Okay, it is -2, it is 2 4s are 8, -3, and this is -2. This should be -2. Right, now it's correct. So because m is 1, so 1 multiplied by y3, it is -3, and n is 2, so 2 multiplied by -1 is -2. So it should be -5 upon 3. So that should give us 2 comma -5 upon 3. Okay, so this is C. Okay, this is C. But now we want the point D as well. If we are considering B and C, D would be midpoint. If we consider A and B, so D would be dividing the ratio into 2:1. So one at the same. So let us consider as midpoint. So that would be better. So in midpoint form, we know that midpoint simply taking average of x coordinates and y coordinates. So the point of C, what we got is, we can see from here, we got it as 2 comma -5 comma 3 upon 3, correct? So d we already know. So what is the value of d? Sorry, what is the coordinates of b? B is -2, -3, and d is the midpoint. That's what we are trying to consider, because we are considering this to ratio. So I'll write over here b would be -2, -3, correct? So the point d would be x1 plus x2, that is 2, -2, 0, upon comma y1 plus y2. So y1 plus y2 upon, sorry, upon why did I take 0 here? Was it 0? No, right? 2, right? Should be 2. Yeah, because we are taking the midpoint, and for that we are taking average. Okay, so 2, -2, -5/3, and -3, correct? That's what we have to consider. Okay, so what we are getting here is 2 minus 2, 0, 0/2, it is 0. Oh, that's why it was misprint. Okay, and this would be -5, -9, it should be -14 by 3, 3 2s are 6. So this is what we are getting. So this would be 0, -7/3 when we divide numerator and denominator by 2. So that's how we got the point of trisection. This is 1 point, 2, -5/3, and this is the other point, which is 0, -7/3. So that's how what all things we have seen is, we have just revised what all things we are learning since past uh, 2 to 3 weeks. We have seen what are coordinate geometry, and we understood that, yeah, -5/3, that's correct. Let us just check the answers what you have given. Yeah, 6/3, -5/3, that was correct. And what else you have given? -7/3. How about, okay, this is -5/3, right? 6/3, -5/3. But I'm seeing that you have given the answers as -7/3. -7/3 is separate one. Yeah. Okay. So what all things we have seen today? We have just revised all the lectures what we have done about coordinate geometry. We understood what is coordinate geometry, what are the terminologies, and how a point is located, and how their coordinates are written, and what are they called as. And then we have seen what is a distance formula, and how to find the distance between 2 points when their coordinates are given. And when we've seen section formula, we have seen how to find the coordinates of the third point, which is dividing the given line segment when the ratio is given. And we have seen two types, internal section and external section. And we also seen midpoint form, which is derived from internal, and similarly the centroid, the triangle. We have seen area of triangle, how to find area of triangle with the formula. And we have also used a question, an example to solve this. We have checked how, if the 3 points are collinear, we can do that by two methods. That's what I was trying to teach you today, that using area of triangle we can find, that is one way of solving, and using the distance formula, that is the other way of solving. And then there is one more question which we've done to find the trisection, and that's what we got, right? So the trisection was here, even this point and this point. Fine then. So that's it for today. I would like to encourage you to keep solving the questions. And okay, some things happen. I'll just try to reconnect this. Okay, is this not responding? Yeah. Yeah, now it's responding. Okay. So what I was saying is, what all things we have seen in the past 2 to 3 uh, lectures, it's all about coordinate geometry, and we have seen different subsections from the chapter coordinate geometry. And in the coming lectures, we are going to learn about quadratic equations. So keep watching our videos and the lectures, and that's what we are going to start. We are going to start with the quadratic equations. And if you are not subscribed to the channel, please subscribe. And if you're not press the bell icon, please press the bell icon so that you may not miss any update from our side. And please visit our website www.letstute.com for a wide range of courses on maths and science. See you in the next lecture with quadratic equation. Till then, take care. Bye bye.